Okay, in this video, we're going to talk about factoring trinomials. So there are several steps, but they're easy to remember once you get started. And there's more than one way to factor. So you might see box method. Some people use trial and error. This is just the method that I found works best and is easiest for students to remember once they learn the steps. So the first thing you want to do is make sure that it's in standard form so that you have x squared first, and then you have x, and then you have your constant term. So if you ever get one that's not in standard form, go ahead and write it in standard form. And then the first thing we are always going to do with any type of factoring is look for a greatest common factor. So we're going to look at each term and we're going to see, is there anything that they have in common that I can take out? And in this case, 2 goes into 12, 2, and -4. So I am going to take out a 2. I'm going to use parentheses and I'm going to write what's left. So 12x squared divided by 2 is going to give me 6x squared. 2x divided by 2 is going to give me a positive x, and you can leave x or you can write a 1 there. And then -4 divided by 2 is going to give me -2. And we can keep our equals 0. What we're going to do now is we're going to work with just this part. So once we've done that, and we will always do that first, do not forget to do that first. We're going to look at the inside here, and the number in front of the x squared is going to be our a. The number in front of x, which in this case is 1, is going to be our b. And the constant over here that doesn't have a variable is going to be c. Okay, so now what we're going to do is we're going to multiply a times c. So 6 times -2 is going to equal -12. And now I want to use this number, and I want to find factors of this number that add to be 1. Okay, so you can just start listing factors. For example, I know that 1 times 12 is 12, but I want a negative here. So that's really important not to forget about that negative. If this number is negative, one of these two numbers has to be negative. So I could make that a -1. But when I check that, -1 plus 12 is not +1. You could also do 1 and -12. But again, that gives me -11. It doesn't give me +1. So if you need to, guys, use a calculator, find all the factors, and then you'll find the one. You'll get better at it the more you do it. But I happen to know that 4 and 3, when I multiply them, give me 12. And I'm going to need a negative somewhere. So if I look at this sign, this is positive. So I'm going to want the bigger number here to be positive and the smaller one to be negative. But you can do this through trial and error. So 4 plus -3 equals 1, which was what I wanted. So I'm going to use these two numbers now. And I'm going to take those two numbers and I'm going to put whatever a was right here underneath. So I'm going to kind of make fractions here. And then I'm always going to reduce if possible. So -3/6 actually equals -1/2. That's fully reduced. And 4/6 actually equals 2/3, and that's fully reduced. You have to do that or you won't have fully factored form. It won't be simplified, okay? So make sure you do the reducing. And then now all we have to do is write our binomials. And so what we do is we set up our binomials here in parentheses, and we're gonna always start with this bottom number and our variable. So that's gonna be 3, we were using x, and then since that's a +2, we're gonna do +2. This one here is going to start with a 2 on the bottom, and I'm going to get 2x, and it was a -1 on top, so -1. The other thing I do have to remember is that we had this greatest common factor here, and I need to bring that out front. So I'm going to put a 2 there, and then I can have equals 0. So this is actually fully factored form. Okay, so that's fully factored. That's as far as you have to go. Now, I do want to show you one other thing, because sometimes you will see questions that say solve by factoring. So you've got to pay really close attention to the directions. If we were going to solve by factoring, we couldn't stop here. We would take what we have here, which is this, and in order to solve, all you have to do is take each factor. So this one, 3x plus 2, and set it equal to 0. And this one, 2x minus 1, and set it equal to 0, and then solve. Now, I'm not going to put 2 equal to 0 because does this make sense to you? 2 equals 0? Nope, that doesn't make sense. If it had an x out front, then I would definitely write that one as well. Okay, but we're going to solve these two, and so we subtract 2. We get 3x equals -2, and then we divide by 3. So x is equal to -2/3. That's one of my solutions. And then here I'm going to move my 1 over, and I get 2x equals 1, divide by 2, x equals 1/2. So positive 1/2 and negative 2/3 would be the solutions to this if you were asked to solve. But if you are just asked to factor, then you need to stop here. So pay really close attention to the directions, okay? Let's look at another one. Okay, on this one, it is not in the right form. You see we have 15x, 2x cubed, negative 13x squared. We want this to go from highest exponent to lowest. So we are going to rewrite this. We're going to write our 2x cubed first. Then we're going to write our negative 13x squared. Excuse me. And then we're going to write our 15x. So now we go from 3, 2, and we have a 1 there. So we're going from highest to lowest. So that's good. The first thing we will always do after that is look for a greatest common factor. Now, if you see 2, negative 13, and 15, there is no greatest common factor between these. However, they all have x's. And the lowest number of x's I have is x to the first power. So I do need to take that out. And then that's gonna leave me with 2x squared, because when I divide this by x, I get 2x squared. This times this equals that. So you can always check. And I'm going to have negative 13x plus 15. If you're ever unsure, distribute this back in and make sure you get what you have up here, okay? So now that I've done that, now I can label everything. I'm going to have a is going to be the number in front of x squared, b is the number in front of x, and c is the number without the variable, the constant. So now we just do a times c. So 2 times 15 is going to give me a positive 30. Now, this is the number I'm going to work with. I want to find factors of 30 that add to be negative 13, okay? And so you could just start listing them if you wanted to, but I know that 3 times 10 equals 30, and 3 plus 10 is positive 13, but I want a negative. I want this to be negative 13, so I can make both of them negative. Negative 3 times negative 10 is positive 30, and negative 3 plus negative 10, when we add those, equals negative 13. So that's what I wanted. Now, if this number is positive, guys, these signs have to be the same. So you will either have 2 negatives or 2 positives. So we're going to take those two numbers, and we are going to put a underneath. In this case, a was 2. This one can't be reduced at all, so I'm good there. But here, this one can be reduced. Remember, you have to reduce your fractions if they can be reduced. So this is going to be negative 5 over 1. We're going to put a 1 underneath because we do need the fraction to write the binomial. Yes, negative 10 divided by 2 is just negative 5. But for this instance, we're going to put a 1 underneath. Now we are going to write our binomials. So bottom number, which is 2 here with our variable, and then our top number, which is negative 3. Bottom number here with our variable, so you can write 1x or just x is fine. And then our top number, which was negative 5. We have to remember to bring this greatest common factor out front. And then I can set it equal to 0. So now it asked me to write it in factored form. This is fully factored, but I want to show you this. If you were asked to solve, because you will be on a lot of problems, and you have factored to this point, okay, if you have this, I'm obviously going to set this one equal to 0 to solve, like we talked about on the other one. I'm going to set this one equal to 0 to solve. But if this has an x out front, 1x, 2x, doesn't matter, whatever's out front, if it has an x, I have to set that equal to 0 also. So in this case, x equals 0 is one of my answers. It's one of my x-intercepts. It's one of my solutions. And then I'm going to solve this one. So when you move this 3, you get 2x equals 3, and when we divide by 2, we get x equals 3/2. So we're good there. And then I just move the 5 over here, and I get x equals 5. So in this instance, there's actually 3 solutions, okay? All right, looking at this one, I showed you this one because this one is in standard form, but there is an ugly negative out front here, that negative 2x. And so we don't want to factor if this first term is negative. So I would look and I would go, okay, 2, 13, and 21 don't have any greatest common factors, so I am simply going to take out a negative 1. Now, when I take out a negative, what it does is it changes all of the signs. Negative 2x squared divided by negative 1 is a positive 2x squared. 13x divided by negative 1 is a negative 13x. And negative 21 divided by negative 1 is a positive 21. So it changed every single sign inside. Okay, now I'm going to work with the inside again. This is a, this is B, this is C. Hopefully you're getting this part. So A is 2, I'm going to multiply by C. So 2 times 21 is equal to 42. I need to find factors of 42 that add to be negative 13. Now remember, this is positive. So I know that in order to get a negative 13, both of these numbers have to be negative. And so for this, I can get negative 6 and negative 7. And again, guys, you'll get better at this part. If you just need to list all the factors you can think of 42, do that. But negative 6 plus negative 7 is equal to negative 13. So that's what I wanted. So I'm going to use these two numbers. And I'm going to put A underneath. Now, this one's good. Can't be reduced, but this one has to be reduced. Negative 6 divided by 2 is negative 3, but remember we want a fraction in this case, so we're going to put the 1 there. And we're going to write our binomials. So this one's going to be 1x minus the 3 that's on top because it's negative. And this one is going to be 2x, and we have a negative 7, so minus 7. We are going to remember to bring that greatest common factor down. Otherwise, you don't have something that will give you this form that you started with. If you wanted to check this, this is fully factored. I'm done here because that's all that, oh, no, but asked me to solve. I'm not done. But this is fully factored, and if you wanted to check to see that that was correct, you could just multiply all this out, and you should get what you started with. If you forget this negative 1 here, that won't happen. So again, we've been solving. So this should be fairly easy. In this case, I have a negative 1 out front. If I set that equal to 0, I'm going to get negative 1 equals 0, and that doesn't make sense. So I'm just going to have x minus 3 equals 0 and 2x minus 7 equals 0. When I solve this one, I get x equals 3. And when you solve this one, you get x equals 7 halves. Okay, this is just solving a linear equation. So these would be my solutions for this one since it said to solve. So pay attention to directions because this said solve. And if I hadn't have done that, I would have gotten it wrong. I would have lost the points. Okay, last problem here, and this one's a little bit different because this is not actually a trinomial, but these show up a lot. So I want to show you a couple things. I could actually write this one as a trinomial. I could write 9x squared. We notice that the middle term with the x is missing, so I could write 0x minus 16 equals 0. And then I could actually go about factoring this the exact same way that we did the others. However, this is a very special form. This is a difference of perfect squares, and I want you to recognize these. I don't want you to take the long way for these. A difference of perfect squares means we have to have subtraction, that's our difference part, and then everything has to be a perfect square. So 9 is a perfect square. If I take the square root of it, I get 3. I don't get an ugly decimal. The square root of x squared is x, and the square root of 16 is 4, another whole number. So everything's a perfect square. So when that happens, here's what we're going to do. We're just going to set up our binomials. We're going to say, what's the square root of 9? Well, that's 3, so each one gets a 3. What's the square root of 16? That's 4, so each one gets a 4. The square root of x is x, so obviously we're going to have these x's here. And then one of them is plus, and one of them gets a subtraction sign. And it doesn't matter what order you put your binomials in. So this is fully factored. I could get the same thing using this method and what we did before. Okay, if I put a 0 in the middle, but I want you to recognize this. Now, if you wanted to check this, and you have this here, 3x plus 4 times 3x minus 4, all I would need to do is FOIL. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. 4 times negative 3x is positive 12x, and 4 times negative 4 is negative 16. Those two cancel out. Negative 12 plus 12 is 0, and you're left with 9x squared minus 16. And I can have my zeros here. So that does work. So that's a good way to check your answer after you factored if you need to. But look for this form. It has to be subtraction though, okay? Okay, on this last slide, I've just basically written out the steps here that we've been using. If you want to take a minute and pause this and write those down so that you have them and they're a little bit easier to memorize. But you've seen the steps and hopefully that helps you to factor. Okay, we'll see you in the next video.